So first of all, for those who haven't been to one of these before, we hold these irregularly, maybe on average once every 2 years. We've been doing it, and the pandemic certainly put a bump in our rhythm. The last one of these was in 2022, so a lot has happened since then, and we're going to be hearing about a lot of new things today. And now, just a few logistics. So everything is in this room. Okay, so if you just stay close to this room, you can't get lost. Bathrooms are just out here in the hallway. Men's room is here. Women's room is just past the crossway with the elevators, just a little bit further down. Um, so lunch and the dinner tonight will also be in here. We'll have a bit of a break before dinner if you want to actually get outside and walk around. It's a beautiful part of the campus. If you haven't been here before, the building will be unlocked, so you can get back in and just come back up to the fourth floor. Some information for speakers. So I sent out a bunch of instructions about, some complicated thing about joining Zoom and, making sure that the people who are remote can see your slides. Turns out all that is unnecessary. All right. You can just get up and give a normal talk. And I'll probably have to remind speakers that they don't actually need to worry about the Zoom link. He over here is doing our AV, is going to use his wizardry to project the slides on Zoom himself. So we don't need to worry about that here in the room. Similarly, for people who are remote and on Zoom, and I know there are some people online right now, you should be able to, if you want to ask a question, just unmute and speak. The room has speakers. The sound is being piped from the Zoom session is being piped through those speakers, so we should be able to hear you. The speaker at least has a microphone, but there is also a room mic somewhere that so people in the room can also ask questions, and we should be able to hear that online. Okay, but maybe speakers will need to repeat questions. We'll see how well that works. All right. Okay, so what are we going to talk about over the next day and a half? Let me just give a very brief overview because not everybody is going to be familiar with all parts of the project. And so just give you some names of things that you're likely to hear about and how the pieces fit together. So the core runtime is called Legion, and that's an implicit task-based distributed runtime. But below it is a level called Realm that's a more explicit, or it actually is an explicit task-based distributed runtime. So in Realm, everything is spelled out. All the dependencies between the tasks are explicit. And Realm serves as the portability layer between different pieces, different hardware. Legion is a much higher level where the tasks and the dependencies between the tasks are not explicit, and those have to be inferred and then converted into the explicit task graph that Realm consumes. Below Realm, between Realm and the hardware, there actually sit multiple communication layers. So the one that we have used the most and for the longest time is GasNet and more recently GasNet EX from Lawrence Berkeley Lab. This is the layer that supports the DOE's preferred networks. In particular, it's the only communication layer that currently supports Slingshot, and so we use it exclusively on the DOE's leadership class machines. But more recently, work at NVIDIA has built a UCX backend that will run on EFA and InfiniBand and is used in other contexts and some of the contexts outside the DOE. And then a lot of what you're going to hear about over the next day and a half are the things built on top of Legion. So we'll hear about Regent, which is a programming language built on top of Legion. It's very close. Basically, it provides syntax and compiler support for Legion. We'll talk about Pigeon, which is a Regent functionality essentially in Python. Okay. We'll hear about Flexi as a multi-physics framework from Los Alamos. FlexFlow is a deep learning framework built on top of Legion. SPDistal is a sparse matrix, sparse tensor algebra library built on top of Legion, and it plays a role in some other projects, which is why we're going to talk about it in particular. And we'll hear about Legate, the project from NVIDIA that is building a runtime for accelerating Python computations on top of Legion. All right, and then there's some pieces on top of legate and SP distal that you'll hear about. In particular, we'll hear about CuPy numeric. Used to be called Q-numeric until 2 weeks ago. All right, so if you think there's another version, there's not. It's the same thing. It's got a new name. Legate sparse, which is the a legate library that leverages SP distal. All right, and then legate JAX, so a port of JAX onto the legate framework that interfaces with Legion in a very interesting way, and I'll let Jeremy explain that. Okay, but it's kind of illustrated here in this complicated picture. And finally, there's some just standalone apps on top of Legion that we'll hear about. So HTR from the PSAP Center at Stanford and radio camera project down at Caltech. All right, and there are other applications, and so, but with that aren't going to have full-length talks here in the meeting. But these are the things you're going to hear about. This is kind of a general picture of how things fit together, and other people will give you a version of this slide again when they get up and give their specific talk on their piece of the overall project and ecosystem. And with that, oh, I almost forgot. And there's some tools that don't fit into this picture. So I just list them on the side, but you'll hear about Legion Prof, probably hear something about Legion Spy and about the Legion Fuzzer as well.